Hello, this video is meant to show a comparison between two specific reinforced concrete specimens that were tested at Virginia Tech Structures Laboratory. This is seismic strengthening, and this is two specimens that were part of a program that incorporated 14 different large-scale reinforced concrete test specimens tested to failure. On the photo of the left, you see the hydraulic actuator connected to the reinforced concrete specimen in the background. And on the photo on the right, you see the test setup where you can see the hydraulic actuator connected to one test specimen. After that is tested, then the actuator is shifted over to the opposite side where they can test a second specimen and then cycle through to test, again, a total of 14 different large-scale specimens. This specimen, CD3, or cantilever diaphragm number 3, is using the CFRP bonded laminates anchored with the traditional FRP anchors. There were many different configurations used, but this is a good depiction to compare, where you have, again, the bonded laminates and then anchored at the termination points with the FRP anchors, but then also along the length, a very robust anchorage plan using the traditional FRP anchors. At the very peak performance of the specimen, the maximum recorded strains in the CFRP bonded laminate were 0.4%, or 0.004. You can see on the photo on the bottom at the end, just past peak, those FRP anchors failed by pullout and some rupture of the FRP laminate. This next slide is showing you a video that will depict the testing of CD14, which uses the same bonded laminates, but is anchored with the ductile FRP anchor plates. You can see here as they start the test, you'll slowly notice as the actuator is slowly pushing and pulling on the reinforced concrete specimen. You eventually achieve the ultimate performance as it moves to the peak strength right here is the peak. And then after the peak, it then reduces in strength. You can see the strains are well above 0.8. So in this specimen, we've got well beyond. In fact, double the strains that were recorded using the FRP anchors we're able to achieve using these ductile FRP anchor plates. Extremely improved performance and better failure mode. You can see again the photo of the specimen on the left, CD3, with the traditional FRP anchors where the anchors have pulled out. Notice on the right, this is post-peak on this specimen where none of the anchor plates have pulled out, none of the anchors have failed. They're all able to hold on, transfer that load from the laminates very, very effectively and efficiently, and achieve not only higher peak strains, but higher peak performance, higher peak ultimate loads, and a better crack pattern. You want that distributed crack pattern because that's what's distributing your load and absorbing your energy, creating your ductility, which is what we're looking for in seismic responsive specimens. We're very excited about this development.